Now we know that x of n is the time representation and ck's and x omega are the frequency representation. Why is it called ck's and x omega the frequency representation? The reason can be found from the synthesis equation. Notice that if I have ck's calculated from the analysis, to construct the original sequence, I just plug in this form. Or if I have x of omega, I can reconstruct x of n through this integration from 0 to 2 pi x of omega e plus j omega n d omega. So x of omega is a frequency representation of x of n, because from x of omega we can reconstruct x of n perfectly. So from this perspective, they are the same. Why is x of omega a frequency representation and x of n a time domain representation? Is simply x of n is for time, omega is for frequency. Hence, this is the distinction why we call x of n the time representation, x of omega the frequency representation. Now, Fourier series, Fourier transform is amazing. It shows that the time signal can be represented as a frequency representation, because actually ck's are nothing but values of which frequencies that we are interested in that are needed to reconstruct x of n. So let us now study this very carefully. Fourier says that for periodic signal, all we need for n sample periodic, all we need is from the zero frequency, because k equals to 0 basically means when this is 0, this is j 2 pi times 0 divided by n, this is 0. The 0 frequency all the way up to n minus 1 frequency. So Fourier says that when to reconstruct x of n perfectly, we only need some of the complex exponential, not all. Of course, for aperiodic signal, we need all. Well, all means from 0 to 2 pi continuous frequencies. Now, what's the other interesting thing is, this equation, the synthesis equation, shows us clearly what Fourier is trying to teach us. A time domain signal is broken down into the sum of complex exponential of different frequency weighted by ck's, the Fourier coefficients. The Fourier coefficients tells us the magnitude and the phase that we need to introduce to the complex exponential to reconstruct x of n. To interpret, the magnitude will tell us how large the signal of complex exponential at this particular k is, as well as how much we should phase shift it by to reconstruct perfectly. And hence, the interpretations of ck's will now tell us at which values of frequency there are magnitude, there are important in the sense that they would be used to reconstruct. If of course ck is 0 at that value, means that no frequency is needed at that particular ck. So once you understand that actually ck being under analysis is used in the synthesis, then you understand the interpretations of ck's. So let us go back to this particular example. It shows us for this periodic signal, these 4 ones from C0 to C3 and all 0 and repeating, we only need complex exponential of this magnitude. Some are zeros, and with this phase to reconstruct perfectly this periodic sequence. So go ahead and take this found ck's and multiply by the complex exponential e plus j 2 pi over n k n ck to reconstruct x of n. So once you can take the ck's, plug in this equation, you will reconstruct x of n perfectly. Thank you.